Hello, everyone. Thanks for joining in for the week 7 of Cube for All. We have successfully crossed 6 weeks and we have covered a lot of topics around modernization and monitoring and debugging Kubernetes issues. So, this week we are going to talk about another interesting topic, which is about running Spark on Kubernetes. Last week we saw running distributed databases on MongoDB. So some of those policies and concepts apply here as well, but widely I'll be talking about the Spark architecture, how to configure master and worker nodes, and create a scalable cluster, and also show you some Scala workloads and Jupyter notebooks and how to run them, and some of the troubleshooting tips around this. All right, so let me quickly walk you through what we covered last week, because some of these concepts still apply for running Spark as well, because we are running a distributed environment on another distributed environment. All right, so last week we saw how we could run MongoDB in a distributed mode on Kubernetes environment. So we touch base on what are the different types of access modes we have, what type of launch modes are available through gopaddle, and what are ordinals, how to scale such distributed environments, what are partitions, how do you update a stateful application, and some of the persistent volumes, right? So typically any of these stateful applications can be accessed in the headless mode. So these services can be accessed using a specific format. Say the service name followed by your namespace followed by your cluster name. So this gives you a fully qualified name for accessing these services, either within the cluster or even within the same namespace itself, right? So we are going to borrow these concepts in today's deployment as well. And we are going to expose a few ports externally. For instance, if we are going to bring up Spark and Jupyter notebooks as two separate deployments. So in order to make these applications talk to each other, we are going to open up a few external ports, and we are going to launch them using Notepad. So as we talked about it last week as well, we do not have support for ingress with the load balancer in a community edition. Whereas if you want to try out, with the TLS and the load balancer setup, you may want to try out the gopaddle Enterprise or the SaaS editions. Ordinals are typically the suffix that comes up along with a service name or a replica name. So if we scale up the number of replicas within a service, you get incremental ordinal numbers. And you can reference these replicas based on these ordinal numbers. You can program this, and you can add init containers in such a way that you can configure your environment based on the ordinal numbers. So scaling also, we saw how to scale what happens when you do the scaling, and how these init containers play a role, how to partition the updates, and how your persistent volumes do not get changed if you use the right selector. So we covered all of this last week, and this is equally important to understand these concepts even in the case of Spark. So we had a review of this now. So let's jump in and then see what is Spark and how we can go about configuring it. So Spark, as we know, is one of the popular distributed data processing framework, and it's heavily used in case of processing large amounts of big data workloads, and also running machine learning algorithms. So it gives you additional capacity to process. So it has in-memory processing, and it can be parallelized. So it gives you a real-time processing environment. So it makes use of the data in the form of resilient distributed data set. RDD is likely an older concept. With the later versions, you get the data sets themselves, which are, you have the schematic validations at compile time and all that. So ultimately, the concept is the same. So these data sets are resilient in the sense, if there is any data that is lost, you can maintain these data in the cache, and then you can bring back those data. So that's why it is resilient, and it is distributed in the sense the Spark itself follows a master and a worker concept. So all the work get distributed across the worker nodes, right? So these data sets are divided into partitions, and these partitions are handed over to different worker nodes, right? So that way it is all distributed, and it is cached, and it can be persisted as well. And we have two different types of activities that we can perform on these data. One is a transaction, transformation, another is the action. Right? Transformation takes the data that is available and it transforms into a new set of data. Right? While actions act upon the data and produce a different type of a result. Right? So we'll see how the whole thing works in the next slide. And when you are submitting these transactions, transformations, and actions, you can provide them in the form of jobs. And these jobs can be batch. You can run them as one program, and it completes and comes out, or it can be an interactive shell mode, or it can constantly monitor for certain activities and events, and then constantly process the data. For instance, you want to find out like scrape and then stream the amount of say social media followers and their activities. You can constantly monitor and then process that data, right? um, Spark also provides some set of built-in libraries for interacting in the form of SQL commands, or doing some of the graph processing or AML. So it has built-in libraries, and you can use your programming languages of your choice, like Java, Scala, Python, or R. Right? So this is the overall architecture of how a Spark application would work on a Spark cluster. So it starts with an application. You can see an application is another program with a couple of transformations and actions, and each of these are converted into separate jobs, and this is run inside a Spark driver. So application itself creates what is called as a Spark context, within which this whole set of jobs are initially analyzed, and then an execution plan is created, right? So a job is then analyzed and split into multiple stages, which is again a sequence of stages, and each stage has a couple of tasks, right? And these tasks are then handed over. This whole execution plan is handed over to the master server, right? The master server, the role of this master server is to allocate worker nodes, find out how much of a capacity is available, and allocate a few worker nodes, and provision the executors where these tasks can be run, right? And it also creates partitions. So it looks at the RDD, which is the resilient data set, and then creates multiple partitions based on the application requirement and as well as based on the worker capacity. So it creates partitions and then distributes them across different worker nodes and executors, right? So within the worker node, we get an execution environment. So this is nothing but a JVM, inside which we will be creating multiple cores. So core tells you how many parallel tasks you can run. So if you have more cores, it means you can run more parallel tasks within the same executor, right? So as you see here, you have two worker nodes, and then each has an executor environment with two cores. So each core runs a separate task, and each task works on a particular partition of data. So once all these tasks are complete, so the Spark driver maintains information about all these executors that are distributed, and then the executor sends these results back to the Spark driver, where the final result is displayed, right? So this is the overall architecture. So you can set let's if we look at the Bitnami setup, so this is how it is configured. If you look at the master server, you have a separate variable in your Docker image which says whether it is running in the master mode, or if it is Spark mode is set to worker, then it mentions it is a worker mode. right? And you can configure the corresponding master URL to to know where to connect back whenever a new instance comes or any kind of resource allocation requirements come in, right? So you have a Spark master URL, and it also have a worker memory, right? It says how much of memory to be allocated for this particular worker node, right? And you also have the number of cores that you have to set. If you increase the number of cores, then you can run those many number of parallel tasks. Now, this is the overview. Now, I've actually configured this Spark cluster, and I already have the Spark cluster running. The way I got this up is by subscribing to the application template that is available in the marketplace. You can actually search for the Spark and you can subscribe. You've seen how to subscribe these marketplace templates last week, and I've subscribed this marketplace template, and I have a copy of that in my local environment. So let's see. Take a look at the Spark and a Spark template. Okay, so here we have two services, master and worker. As I mentioned earlier, master has a couple of envs. It just says the Spark mode, and here it is set to master, right? And this is all we need, and a couple of other configuration. If we want a SSL based communication, we can enable all of these. But by default, Spark Master comes up on port 7077. So we can connect, the application can actually connect to this Spark Master over this port number. And we also have a Spark Master Web UI, which is on port 8080, right? So this is an external port. And since we are going to connect to the Spark Master as well, using its service name, I mean, we don't really have to open up any firewall ports as of now. So it's going to be accessed using the headless service name. So we can just leave it as is. So if we look at the network rules, okay, so we have opened up if we want to access this dashboard outside. And then 7077 is another port, and it is not open in the network policy. So if we actually take a look at this, there is no other network policy required. Similarly, for the Spark worker, we have a couple of environment variables. So it says Spark mode as worker mode. It has the Spark master endpoint. Since it's all within the same application template, we can just use the service name here. So the service name is Spark master. We're just pointing to that, and then its port number. Right. So let's move on to the Spark worker web UI. Now this is running on port 8081, and we have worker cores as one. Right. So only one task can run at a time. Now, in order to run the Spark cluster, we must make sure at least we cater to this requirement of 1 GB. So if we are bringing up, say, two worker nodes, which means two replicas, then we need at least 2 GB of memory just for the worker nodes alone, right? So we have to provision the environment in such a way that we have enough capacity to run these workloads. Now, let's take a look at the number of replicas that are configured. So if we look at the Spark worker deployment policy, we have 2 replicas. Now, this is what is there in the template, but I have actually increased the number of the cores in a running application, which I can directly edit from here. So let's take the services and the worker. And if I look at the policies, so we have 2 replicas, and I can go and increase the number of replicas by just increasing the count. We don't need an init container, just like how MongoDB required an init container. We don't need that because worker knows which master to connect back, and master would get to know about the new worker nodes that are available, and it will automatically register and start distributing the workloads. So if we look at the replicas, right now there are only 2. So it's going to bring up the third one. And we have the ordinals 0, 1, and 2 now, right? So the cluster has scaled up, and we have 3 worker nodes that are available. Now let's go back to the Spark master to see. So one yet another configuration that we wanted to look at is the number of cores, right? So let's take a look at the environment variables that we have. So in this case, we have, say, I have increased the cores to 2, and we can also increase it to any number that we desire. So for the time being, I'm going to increase it to, say, 3, so which means it can run 3 parallel jobs. So I'm going to change this and increase the value to 3. All right, and when I commit this, this is going to create a rolling update. Right, so this is updating the cluster, and the cluster would have come up, updated all the replicas now. So I can access the cluster UI dashboard from here, right? So I have this master dashboard available at this endpoint. So as you can see, there are 3 worker nodes, and there are no running applications. So this is a previous one. So let's ignore this for the time being. I've been testing something and it's showing up in the completed list. But we have still it is showing 2 cores. Let's just refresh it to see if it's updated. So it looks like it is still updating these replicas. Yeah, so it is still updating the replicas. Okay, so it should have come up. Okay, so looks like it's taking time to update, but we will get to see this in a few minutes, right? So let's go back and then take a look at the Jupyter application. So before we get there, so we can also run the Spark batch jobs and the interactive jobs from here, right? So let's go to the Spark master. So I'm going to run a few Scala interactive application here. So I'll go to the replicas and I'm going to run a Scala application here. Okay, so I have a sample program which I'm going to run in the interactive mode. Right, so this is a Scala application. Okay, so we get into the Spark shell. So this is going to open the Spark shell, and we can execute the interactive application. So in the meantime, let's check if the cluster is reflecting the cores, right? So yeah, so you can see that the previous worker nodes are all are dead, and new worker nodes have come up with the increased core capacity, right? So let's go to this and see whether we can execute the sample application. So it's just taking time to open up the shell. Yeah, so we can run our interactive applications from here as well. So you can see that it's importing certain libraries, and it's adding a data set, and it is converting to a data frame, and then we will be able to see the data frames. So you generally, these interactive shells are used at the time of development. But for more sophisticated, batch jobs, you can also use Jupyter, right? So in that case, if you want to run a Python notebooks, you can go to the app templates and then subscribe to Jupyter notebooks. I've actually subscribed Jupyter, and I'm going to launch this application. So I'm going to show you how to launch a Jupyter notebook here. So I'm giving it a name. When I subscribe, it automatically creates a release from where you can launch. So this release has this distribution called Jupyter, and it has the image, corresponding image. I'm launching this on a Google environment. If you're using a community edition, it will be the local microcreators environment. And then you can choose the storage class or the policy that you need. Since this is a stateful application, so it requires a storage policy to be chosen. So I'm choosing the cluster provided storage driver. And then we can expose the Jupyter notebook on a particular endpoint, on a particular node port. So since the 30,000 and 30,001 are already used for the Spark master and the worker, I'm actually choosing 30,005. And we can just move on. And if we need to select any node where it has to be provisioned, we can choose the node selectors. Otherwise, we can go ahead and then launch this. Now, this is going to bring up the Jupyter notebook. Let's see if the application has come up. So it's still in creating state. So in the meantime, let's go back to the Spark and then see how the master has registered the worker nodes, right? So if we go to the replicas and take a look at the container logs. Okay, so this is the container log, and we can see that as soon as a new worker node comes up, the worker node communicates back to the master, and the master registers the worker node. So it automatically scales up or scales down, right? So even if I terminate one of the worker nodes, master will get to know about it, and it will automatically, register it, and then know how to distribute those, tasks and the data sets to these worker nodes, right? Let's see. Let's go back to the Jupyter application now. Okay, so the service has come up, and we have the container is still coming up. Sometimes this takes a little while to update, but we can go inside the replica to see if the container is running. So it is running, right? So we can take a look at the current logs here. Okay, so it tells us how to connect to this. It has given us a token, right? So let's make a note of this token, and we will get the endpoint in a while, right? So yeah, so let's go to the applications. From Jupyter, we can grab the endpoint to access the Jupyter notebook. So here we get the endpoint, and we access it using the token that we have. So looks like it's still coming up. So it's taking time. Okay, so there we go. So we have access to the Jupyter notebook. I have a sample program which I'm going to upload and run. So this is going to connect to the Spark cluster, and then it is going to execute a few tasks. So I'll upload this program. Let me show you what I have here. So it creates a data frame. It first, let's load this. So it connects to the remote Spark cluster using the headless service name on the port 7077, right? And then it also sets up the app name as demo app, and it also creates a config out of this, and then creates a data frame. And we are trying to execute a SQL-like query on this a data frame, and then we are going to print the collection, and then we'll close the session and we'll come out. So this is a very simple demo application. So let us run this program to see how this works. So I'm going to run this notebook. So we have completed the steps 1, 2, 3, and now we are in the 4th step. So we can see how it executes by looking at the Jupyter container logs to see if this task is completed. So looks like there is some exception. So I really wanted to show this exception because this is a very common problem that you might face, because you're running a Jupyter environment separately and you have the Spark environment separately, and there can be mismatches with respect to the versions. So we have documented this problem in our help documents. If you look for Spark, and you will come across this particular issue which says invalid class exception. So this happens when you have a PySpark version incompatibility between your Spark cluster and your Jupyter environment, right? So if we go back to our Jupyter terminal, container terminal, so we can check the PySpark version here. So we see that it is 312, and we can also see what is there on the master. So let's access the master terminal and then check the Spark version. So let's go back to the container terminal and then check the version here. Yeah. So in this case, we get 301, right? Whereas in our Jupyter higher version, the Scala version is 2.12.10 and JDK is 1.80. All the major minor versions for Scala and the JDK all match. However, this Spark version is different. So we need to either upgrade the cluster or downgrade the environment, downgrade the PySpark environment here, right? So we can downgrade it. In this case, this is a simpler option. So we can just run this pip install and go to the specific version of PySpark. So this will uninstall the previous PySpark version and then bring it to this particular version. Right now, with this change, we should be able to run the Jupyter notebook. So let's rerun this. So terminate the kernel and then rerun the whole code again. So while this is happening, let's go back to our Spark master and see how this workload is distributed. Right. So we have, the demo app which just got finished. Let's see. Yeah. So let's refresh this again to see how it has run. So you can see that this app is still running, and this is the name of the app. It has used 9 cores because there are 3 nodes and each with 3 cores. It has used 9 cores, and per executed, this is 1 GB. So that's what we have set in our configuration. And it has, I think it should have completed by now. Okay, looks like it's still running. You can take a look at the application logs by accessing this endpoint. Yeah, so this is the demo app, and it shows you can also access the standard out and standard error across each of these worker nodes. As we know, the worker node is is available on the node port, but with 30,000 endpoint. So I'm going to just reuse the same endpoint here. Unfortunately, this has come up with the private IP, so I'm going to change this to the cluster node IP along with 30,000. So this should give us the application logs on the first worker node, right? And you can change this executor ID is to, so you know from where I have actually accessed it from here. So this is on the first worker node. So you can also get the standard errors. If there are any errors, you can also get std out or std error to see if there are any error logs. So it looks like this is still, failing. So another reason for failure could be because of the Spark environment has some local cache, and it may still be having issues because of that. So one suggestion would be to go restart your worker nodes, in which case I'm going to open up the applications, Spark. And I'm going to restart the replicas. While I stop this execution here, I'm going to restart the replicas. Right, so to restart the replicas, I can just delete these replicas, and this is going to bring up at another replica, because we have set the deployment policy to 3, so it will automatically bring up new replicas. So this is going to take us some time. In the meantime, let's see how the Spark server is reflecting the changes. So it's still not updated, so it's still terminating those replicas. So once we have the new worker set, like, we should be able to see it here. Yeah, so we are, all these worker nodes are dead, and it should bring up the new worker nodes. So in our UI, we should be able to see these worker nodes. So yeah, these are restarted a few seconds ago, so it should be there in our dashboard also. Yeah, we have the 3 worker nodes now. Let us rerun the same application this time. Restart it. So it's creating the data frame. And the application ID would have changed by now. So we can just use the same URL and then use the different application ID. We can grab the application ID from here. So let's take this app ID and then use it in our, okay, looks like I've closed it. So let's open up another tab and see this. So we're going to use the 30,000 as the endpoint, 30,000 as a port number. So it looks like it has still having the same problem. So it looks like it is still showing some incompatible versions. No. So this step has completed. Now it is trying to print. So it looks like it's still showing the older one. Let's wait a couple of seconds to see if it has finished the execution. So we are in the Jupyter environment application. So let's take a look at the logs. So it's still waiting on the Spark application to finish. Okay, let me retry this once again. because we have changed the PySpark version, so it should ultimately run. So let's refresh this once and then rerun it. So let's grab the application ID again, and then see if it still works. So let's change the application ID in the URL. So it looks like it's still getting executed, and in our logs, okay, looks like it's still happening. So this is what happens. So this is a common problem with respect to the the PySpark version. Let's again try, right? Spark shell. Okay, so this version that we need to update can be done by just doing a pip install, but let's check the version before we do. Okay, so let me exit from here. So let's say PySpark version. Okay, it's still pointing to 312, so that's strange. So we updated it, but looks like it has not updated it. So I'm going to update this once again. So this is only a temporary solution, because if at all, this container got restarted or if this replica got rescheduled, then all your changes are lost. So the permanent solution would be to update your image. So you can actually grab this image. This is available in the public repository. So I'm going to show you from where you can take this image. You have to prepare using this as the base image. You can, include this in your Docker file and then update your image accordingly. So we are not providing this as a part of the marketplace itself, for the reason that the Spark cluster may get updated in future, and you may want to try it out with a different version of Spark. So since this is a common version compatibility issue, I want to just throw some light onto how to identify this issue and resolve it. Now let's take a look at this updated version. Hopefully, this time it got updated. Okay, so I looks like I'm missing something here. So looks like it's not getting updated for some reason. Okay, so looks like this is not getting updated. Hopefully, we'll find some troubleshooting tips on this. But this is the reason why you see a version incompatibility, because you see the version here is 1312, whereas in your Spark cluster, it is totally a different version, right? So that's one of the reasons why this notebook doesn't get executed. So maybe we can retry this once again to see if this works. So if it doesn't, then probably I will add this to our start scripts and see if it works. But hopefully, we'll do it in the next session. So today, I think we have covered a lot around how to, configure the Spark Master and Spark Worker nodes, how to run a Jupyter notebook by connecting to the remote Spark Master, and how to debug issues like this, or even run some interactive sessions in your PySpark environment, Spark and shell environments. And I hope this gives you a foundation to run these Spark and Jupyter and Scala workloads on Kubernetes. I hope by next session we will have some more answers to these kind of issues, and then we'll touch base on this in the next session. We look forward to you joining us in the next week. So we have some more interesting topics around CI/CD, and we have kind of templatized a lot of these Jenkins or GitHub and GitLab and other pipeline environments. We look forward to seeing you in the next session. Thank you.